Psychological Research BA Honours PSY 05. Well friends, very good morning to all of you. Today we will talk about the norms. As your paper is of psychological research and one of the tools which you used in your to collect the data is psychological testing, and in testing when you use the test, three important characteristics must be fulfilled: reliability, validity and the norms. Now reliability, validity we have already talked in the lectures. So today we will talk about the norms. Actually, just brief introduction then I start you. Norms are the reference point against which the obtained scores of an individual, which we call raw scores, are interpreted. So norms are the reference point against which the raw scores are interpreted. How I can say that whether your intelligence you are higher or lower, your anxiety is more or less, how we can say? I can't say arbitrary. I must have certain standards, and that reference point is called as a norm. Now when we say norms, norms are of the different types. Broadly speaking, norms are classified into two broad categories: developmental norm and within the group norm. So today we will talk about within the group norm and its types. Now let us start. Normally all standardized tests provide some form of within group norms. With such norms, the individual's performance is evaluated in terms of the performance of the most nearly comparable standardization group, as when comparing a child's raw score with that of the children of the same chronological age or in the same school grade. Within the group scores have a uniform and clearly defined quantitative meaning and can be approximately employed in most type of statistical analysis. Now, what I have said, just try to understand. Within the group, that means in a group where you stand, what is your position? And when I have classified two broad category, developmental, which I talk later on, developmental means which are related to your development, mental age, grade norms, this and that. Now within the group means your position in a group, how many people are better than you and how many people are below you. What is your position? 20% higher and 80% lower, your position stands here. So these norms are called as actually the within the group norm. Now these are of various types. The types of within the group norms are: number one, percentile, standard score, T norm, stay 9, and there is 10, so many. So I have mainly telling you about the four prominent used: percentile, standard scores, T norms, stay 9, and these norms are provided in your manuals by the test constructor. Before explaining the different norms, it is necessary to understand the normal distribution, because when I will talk about these norms, the standard distribution will come. So first of all, I just in brief explain you what is standard, what is normal distribution, and then we will talk about the norms. Now standard distribution, yes, which we call normal probability curve. It is a bell-shaped curve, bell-shaped curve. You have seen? Now this curve is a bell-shaped curve, clear? Now in this curve, normal distribution curve will be where mean, median, mode lie at the same point. This is the line, mean. Here median will come, here the mode will come. That is, mean, median, mode are the measure of central tendency. Now if the mean, median, what is median? Median is the score above which 50% and below which 50% are coming. Now see, if this is the central point 50. Now if I draw a graph, it will be balanced, 50 there, 50 here. Now if it is come this side, then I will say 70 here, 30 here. It will not be normal distribution. That we call, when this topic will come, skewness or the kurtosis, the technical terms are used. Normal distribution is that where mean, median are lying at the same point. So, that is why it is a balanced bell shaped curve. Now, this is the mean point you are seeing in the graph. Now, normal distribution curve is divided into two parts, right hand side and the left hand side. Right hand side, the area is divided into plus 1 SD, plus 2 SD, plus 3 SD. Now, this is about the normal distribution curve, which is not the part. I am simply explaining the areas for the norm purpose. On the left hand side, it is minus, in the left hand side, it is minus 1 SD, minus 2 SD and minus 3 SD. Now, listen, the area between mean and plus 1 is, I have written 34.13. It means the total, it is score of the total 100. Now, out of 100, the area between mean and plus 1 SD is 34.13. Suppose a person's getting here 1 SD. Now, what will be his position in the percentile percentage? Mean is 50%, am right? Mean is 50%, mean plus 1 SD 34%. So, that means the persons who are coming on plus 1 SD, their position is 50 plus 34, forget about decimal, 50 plus 34, 84. That means their position in the group is 84th. 16% are above and 84% are below. You come to the plus 2 SD. Now, plus 2 SD 34 plus 1 SD 34, it is 13, 34 plus 13, it is 47. B in between is the median 50. So, 50 plus 47 is the 97. Now, person who is coming on the second SD, his position will be 97. That means 3% above him and remaining below him. Now, if you are getting minus, you are coming on the minus 1 SD. How? I will tell you in the Z score, you are coming on the minus 1 SD. So, again mean and 1 SD is 34, but it is minus. So, 50 minus 34 now. Now, it will be 16. Now, that means when it is 16, that means 16 means 84% are above you and remaining are below you. So, when I say below you, above you, I am telling your position in the group. So, this is called actually within the group norm, and before explaining within the group norm, this concept should be clear to you, because when I come to the Z score, standard score, then I will say if this is, I will calculate, then I will say this is this, this is this. So, is it clear? I think normal distribution curve, mean, median at the same point, right side and left side divided into plus 1 SD, plus 2 SD, plus 3 SD, 1 SD 34.13, 2 SD 13.5 and remaining is 2.14, remaining decimal leave it. Similarly, on the negative side, if it is on the positive side, plus 1 SD, 50 plus 34. If it is on the negative side, it will be 50 minus 34. So, with this introduction, let us start the within the group norm. The first is percentile. Percentile scores are expressed in terms of the percentage of the persons in the standardization of sample who fall below a given raw score. For example, if 28% persons obtain fewer than 50 problems correct on an arithmetic reasoning test, then a raw score of 15 corresponds to 28th percentile, that is P28. A percentile indicates the individual's relative position in the standardization sample on a scale of 100. Percentiles can also be regarded as ranks in a group of 100, except that in ranking it is customary to start counting at the top, the best person in the group receiving a rank of 1 with the percentiles. On the other hand, we begin counting the bottom, so that the lower the percentile, the poorer the individual standing. Now, percentile should not be confused with the familiar percentage. Now, what is percentile? In the percentile, now when a score will tell you that where your position is lying. If a score we say P28, for example, your score telling you P28, that means P28 means subtract from the 100, That means 72 persons are above you and remaining are below you. It is not percentage. Percent simply telling this, but it is telling you your position in the group. Now, when you start building the norms, whether percentile, standard score, Vatina, whatever you talked, we administer the test on a large number of sample, that is normative sample, that we call normative sample. Now, what will be normative sample? It will be of the same age, same group for which we are constructing the test. If I say my test will measure intelligence of 16-year age group, so I will take 1000 students or more than 1000 of 16 year before bringing my test in the market is for the establishment of the norms. So, I will administer and I will calculate the percentile and I will tell you in the manual that where it stands. Now, the later are scores expressed in term of percentage of the correct item. What? Percentage. I have said percentile and percentage is different. The percentage, that is the later because I have just mentioned the word after the percentile. The later are raw scores expressed in terms of percentage of correct items. Percentiles are derived scores expressed in terms of percentage of persons. A raw score lower than any obtained in the standardization sample, I have told you I have taken 1000 and more than that, would have a percentile rank of 0, one higher than any score in the standardization sample would have a percentile rank of 100, that is P100. Percentile scores have several advantages. They are easy to compute and can be readily understood even by a technical untrained person. Moreover, percentiles are universally applicable. They can be used equally well with adults as well as children and are suitable for any type of test, whether it measures aptitude or personality variables. Now, why we prefer percentiles? Most of the tests in the manual you will find that the percentile norm are provided. They are universally applicable. It is not that they will for the applicable of only personality test or interest test on the intelligence test. No. If you come to the, when we will talk about the developmental norm, when we will come about the mental age, that is only and only applicable with the intelligence test, not with the personality, not with the interest, not with the aptitude. Whereas percentile norms are applicable whether it is personality test, whether it is aptitude test, whether it is interest inventory, whether it is intelligence, whether whatever variable you are measuring, it is applicable for all. Number 2, it is easy to compute, calculate and very easy to understand, that we will demonstrate just now that how to do it. Now, now come to the drawback. The main drawback of percentile score arises from the marked inequality of their units, especially at the extremes of distribution. If the distribution of raw scores approximates the normal curve, as is true of most test scores, then raw score of differences near the median or center of the distribution are exaggerated in the percentile transformation, whereas raw score differences near the ends of the distribution greatly shrunk. I have shown you the normal distribution. I am bringing back that again. Now you see, if you see the central part, here the scores are spread 34%, and if you go to the corners only 2.14, here only 13.58. Clear? Usually the scores are normally distributed because you have taken a large sample, normative sample. So drawback is that in the central part there is a more spread, and as we to the tails of the curve, the scores are shrunk, they are constricted. That is the drawback of the percentiles. Now, if you are constructing a test in the future, you consider test, and I am telling you how to calculate percentile norms in the test. Now, to calculate the percentile, the formula is PP is equal to L plus Pn upon 100 minus F upon Fp into I. Now, this P, small p, capital P is percentile. This small p which is on the left part of the capital P, it is which percentile you want. You want your score, where you want to know the position. I want 10th percentile. it will be called P10. I want 20th percentile, it will be P20. I want 40th, it will be P40. I want 50, it will be P50. So, whatever you are calculating, you want to know, that is the small p. Now, L. L is the lower, it is written P, read it as L. It is the lower limit of the class interval in which Pn upon 100 is lying. How it will be? We calculate the interval in which Pn upon 100 is lying, the lower limit of that class interval will be small p. Then sum of the frequencies of P is the lower limit of the class interval in which Pn upon 100 is coming. Capital F, sum of the frequencies of those class intervals which are less in value than the class interval in which Pn upon 100 is coming. You will identify the class interval in which Pn upon 100 is coming. You calculate the sum total of frequency of all the class intervals which are less in value in comparison to that interval. Fp, frequency of the class interval in which Pn upon 100 is lying, and I is the size of the class interval. Now, this was the formula. Now, how see? Now, what you do when you are establishing the percentile norm, what you are supposed to do? First, convert your data into group form, group data, because in the normative sample is not only, I have taken this example of 50 just to explain you, my normative sample is quite large. So, if I start calculating 1, 2, 3 on group, that is, it will be very difficult. And when you convert data into group data means, you see, I have made a class interval 140 to 144, frequency 1. Frequency word means frequently. How many times this score is coming? It is 1. I have counted students who are getting score between 145 to 149, 3. Between 150 to 154, 2. Likewise, we convert our scores into the group form. So, this is your scores and this is your frequencies. Now, how to determine your percentile norm? I have told you the formula. Now, we will see. First of all, what you do? Calculate capital F. Capital F means cumulative frequency. The word cumulation means summation, addition. You add up the frequencies from where? From the lower score, not from the higher score, from the lower score. Now, this frequency is 1, it is 1. Now, this frequency is 3, 1 plus 3 is equal to 4, so capital F is 4. 4 plus 2 is equal to 6, 6 plus 4 is equal to 10, 10 plus 4 is equal to 14, 14 plus 6 is equal to 20, 20 plus 10 is equal to 30, 30 plus 8 is equal to 38, 43 plus 5 is equal to 48, then 47 plus 2, 49, and 49 plus 1, 50. Likewise, if n is 50, it is 50. Now, see, I want to calculate P10. P10, what is the score where 90% above scores will be there and remaining below will be there. So, first of all, calculate P10, the 10% of the 50. So, Pn upon 100, this value is coming, Pn upon 100 is coming, for example, it will come 5. So, identify the class interval where P, that means Pn upon 100, 5 is coming. Now, you see, it is 1, it is 4, it is now 6. 6, that means 4, 5, 6 is coming in the class interval 150 to 154. Now, what was the L? Lower limit of the class interval in which Pn upon 100 is coming. Now, 5 is coming in this class interval, am I right? 6, it is 5. Now, for lower value, subtract 0.5. If you want to know the upper value, upper limit, add plus 1. This score is starting from 150. So, subtract 0.5 in 150, it is 149.5. So, L is 149.5. What was capital F? The sum of the frequencies of those class intervals which are less in value than the class interval in which the Pn upon 100 is coming. Now, Pn upon 100 is coming or lying in which 150 to 154. Which class intervals are less in value? 140, 144, 145 to 149. So, sum of its frequencies already we have calculated 4. So, capital F is 4. Now, small f In the formula, the frequency of the class interval in which Pn upon 100 is lying. Pn upon 100 is lying in this class interval. What is its frequency? 2, not 6. 6 is its cumulative frequency, where we have small f, actual frequency. Now, you have got all the values put up. L 149.5, Pn upon 100 5, capital F minus 4, F 2 into 5. Now, calculate 149 plus 5.2. Now, calculate this value is coming 152. That means, in a test, the person who is getting 152 marks, P10, 90% people are above him and 10% people are below him. His position in the group is determined that 90% are better than him and 90% lower than him. For example, I am constructing a test to measure anxiety. Now, your score suppose is 152. Now, whether I should say you are high anxious or low anxious, how I can say? If without any reference point I say, then interpretation will not be objective. Now, I have calculated percentile norm. Now, P, you want to know 10th, 90% above. This score came out 152. Now, you can interpret with confidence that the person who is getting 152, 90% above and this much below. So, this is your percentile within the group norm. You want to calculate P20. Now, same formula, the answer is coming 159.5. That means, the person who is getting 159, 80% above, 20% below. You want to calculate P30, it is 165.3, 70 above, 30 below. P40, 60 above, 40 below, 169. If the score is 172, that means, if you are getting answer 172, that means 50 above, 50 below. In this way, we calculate the percentile norm, which tells us the position of the individual in the group. Now, one thing I want to add, that P50 and median is one and the same thing. What is median? The above and below which 50% lying, and P50 is above and below 50% lying. So, the first within the group norm which I have explained to you, I have told you how to calculate, that is the percentile norm. The second score is standard scores. It is a very, very popular and in number of tests, this type of norm is used. Now, many tests make use of the standard scores, which are most satisfactory type of the derived scores from most point of view. Standard scores express, listen, underline this line, standard scores express the individual's distance from the mean in terms of standard deviation of the distribution. Distance from the mean in terms of standard deviation in the distribution. How? I will explain to you. Standard scores may be obtained by either linear or non-linear transformation of the original raw scores. When found by a linear transformation, they retain the exact numerical relation of the original raw score, because they are computed by subtracting a constant from each raw score and then dividing the result by another constant. So, all properties of the original distribution of raw scores are duplicated in the distribution of these standard scores. Now, linearly derived standard scores are often designated as standard scores denoted by symbol Z. Z is used to denote standard score. Percentile is, the symbol was PP. Here the symbol is Z, standard score. Calculate SD, the symbol is Z. So, the Z is the symbol of standard score. Now, Z scores can be computed by the formula. What is the formula? Z is equal to x minus m upon ST. X minus m upon ST. What is x? X is your individual score, what the student is getting on your test. M is the group mean and SD is the group standard score standard deviation. Listen, I have told you that when you are establishing the norms, then you take a large normative sample, maybe 1000, maybe 2000, maybe 5000. Larger the sample, more it will be representative, more accuracy of the norms will come. So, you are administering a test, it is the job of the test constructor, not the user. Now, I am constructing a test. So, I will administer my test, for example, on 5000 persons. I have constructed a test that is known as JMPI, Jodhpur Multiphasic Personality Inventory, and for that, for the representative of the normative sample, I took sample from number of states, and then the sample size is large. So, if suppose I am taking a sample of 1000, so I will calculate 1000, that is the group mean of the group 1000, and I will calculate the standard deviation of those 1000 students. So, when you will learn statistics, then you will learn how to calculate the mean and how to calculate the standard deviation. But here I am simply telling you, you simply calculate mean of that 1000 student and standard deviation of the scores of 1000. Now, that score is called group mean and SD will call group standard deviation X. Now, the test you have prepared, I have given the Z norm. Now, you are administering this test on Mr. A. Whatever the score Mr. A is getting, that will be called as the individual score. That means score obtained by the person on a test. Now, see, I have solved it with an example. See, for example, the mean of the group is 60. The normative sample 1000, the mean of the group is 60. This is hypothetical data. SD of the group is 5. Standard deviation is 5. John, I have put a name. John's score on a test is 65 and Ashok's score is 58. Now, the test is with you, the test in your hand, you are doing it. A student whose name is John, he has obtained 65 marks. So, what I will do? I will calculate the standard score by using this formula. Now, what is this formula? Z is equal to X individual score. What is individual score? 65 I have put here, minus M, that is the group mean 60, SD, group SD, that is 5. So, 65 minus 60 upon 5 is equal to 5 upon 5 is equal to plus 1. Why plus? Because 65 is higher than the 60, so it is plus 1. Now, see the next one. Z 58, now Ashok is getting 58 marks. So, 58 X mean of the group is 50 and the group SD is 5. So, 58 minus 60 upon 5 is equal to minus 2 because 50 is less in value, upon 5 it is getting minus 4. So, standard score of John is plus 1 and standard score of Ashok is minus 0.4. Now, interpretation sheet. I have just told you in the normal distribution, and when I defined the standard score, what was standard score? It was distance from the mean in terms of standard deviation. Distance from the mean in terms of standard deviation. Now, John's is getting plus 1 SD. What is standard score? What is Z? Plus 1. So, that means plus 1 Z is equivalent to plus 1 SD. Z score, distance from the mean in terms of standard deviation. Distance from the mean in terms of standard deviation. If standard score is plus 1 Z, it is plus 1 SD. Now, you have seen that the area between mean and plus 1 SD is 34. Mean is 50. So, earlier just few minutes back I told you 50 plus 34 is 84. That means John's, who is getting plus 1 Z score, his percentile score is 50 plus 34, 84. That means 16 persons are above him and remaining are below him. So, Z we will see area from the normal distribution and then we will interpret. Ashok's was getting how much? Minus 0.4. So, we will calculate, that is a system, we will calculate the area which Mr. 0.4, it is 1 which 0.4 which will come here about is coming. So, that we will subtract from the 34 and then we will come to know that where he is standing. So, in this way we calculate the standard scores and then we interpret in terms of their position in the normal distribution curve. Now, you see, in case of John I have explained you Z is plus 1. In normal distribution the area between mean and plus 1 SD which I was just showing you is 34.13. So, total area will be 50 plus 34 is equal to 84. Now, it can be said, it can be interpreted that percentile score of Mr. John is 84, hence 16 persons are better than him and remaining are below him. Clear? So, in this way we calculate the standard scores. Now, we are talking about the norms. I have told you what is the importance of norms. They are the reference point against which we interpret. Developmental and the within the group. Within the group, in this period we have talked about two types. One is percent and second is the standard. So, standard scores I have interpreted, told you that they are the distance from the mean in terms of the SD. So, similarly you can calculate the standard score and then show what area is coming in the normal distribution and you can know the position of the person in the group. In the next class, when I will talk about the developmental norm, then I will tell you what is T norm, what is standard, what is T norm, what is stay9, that we will talk about in the next lecture. So, this was all about the norms within the group norms. Thank you very much. I hope it would be clear to you.